Definition of a reference angle. Let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle theta prime formed by the terminal side of theta and the x-axis. Reference angles are found in quadrants 2, 3, and 4. For an angle that's in the first quadrant, that is your only angle. But when you're dealing with angles that are in between 90 and 180, in other words, greater than 90, but less than 180, when you're finding an angle that has a measure greater than 90 but less than 180, to find theta, you have to subtract 180 degrees minus theta. You have to subtract 180 degrees minus theta. Okay, I'm going to pull this up a little bit closer to you. So to find this angle theta here, we would say 180 minus theta. That is for an angle that is in the second quadrant. Now, for an angle that's in the third quadrant, it's in between 180 and 270. That would be your reference angle, in between 180 and 270. To find theta prime, you will say theta minus 180, because the theta will be larger, so you have to subtract off 180 to find theta prime. And for an angle that is in the fourth quadrant, it's in between 270 and 360. To find theta, you must subtract 360 minus theta to find the theta prime. Okay? So we're going to use those rules on some examples that I have for us to do. So let's look at this first example here. Let's find the reference angles of theta prime for each of the following angles. Find the reference angle theta prime for each of the following angles. Okay? So the first one is 120. All right, so think about it. This is 0 degrees, this is 90, this is 180, and this is 270. If you're going to draw a 120 degree angle, you'll pass the 90 and go on 30 more degrees. Okay? So this is theta, which is 120 degrees. Now think about it. This one's 90 on 30. So you got 90 degrees plus 30 gives you the 120 degrees. So what is the angle left here? That would be your theta prime. So to find theta prime, you will take 180 minus theta. Well, what was theta? It was 120. So 180 degrees minus 120 says that my theta prime is 60. So my reference angle would be 60 for a 120 degree angle that is in quadrant 2. Okay, so our rule told us earlier, when you have an angle that is in the second quadrant, you have to say 180 minus theta. Okay, now let's go to the next angle. Theta is 225. Theta is 225. So we're going to be in quadrant 3. Think about it. If I go all the way around, that is 180. Okay? And if I go on further down, you have to think about 225 minus 180. Doesn't that give us 45? So we got a 45 degree angle there. You always draw it back up to the x-axis. Every reference angle is drawn back to the x-axis. So to find your theta prime, we have, and this is in quadrant 3, you have to say the original theta, 225 minus 180, and that told me that theta prime was 45. Therefore, your reference angle for a 225 degree theta, you have a 45 degree reference angle. Now let's look on to the next one that I have here. Theta is 330. Think about it. 180 is a semicircle. All the way down is 270. Well, I've got to think about it. How much further do I need to go? So, if you think of 360 minus 30, 360 minus 30, I have a 30-degree reference angle. So I must come all the way around so that I have a 30-degree reference angle. So this is where theta is 330. I'm in the fourth quadrant. So to find the reference angle of a fourth quadrant, you take 360 minus 330, gave me 30 degrees. Therefore, the theta that I will be using, or theta prime, that I will be using to evaluate a 330-degree angle will be a 30-degree reference angle. Okay? All right, let's get some more practice on this. I just want to make sure that y'all understand about reference angles and how you determine reference angles. So let's look at this one. Another theta that is in quadrant 4, okay? You go past 180, past 270, on into the fourth quadrant. To find theta prime in the fourth quadrant, you must say 360 minus 345. 360 minus 345, if you subtract there, you end up with a 15-degree reference angle. So that's how I get my 15-degree reference angle from a theta of 345 degrees. Theta prime is 15 degrees. All right, next we have radians, okay? You can keep it in radians, or you can change it to degrees. It doesn't matter. If you change it to degrees, that's 5 pi over 6 times 180 over pi. Okay? So the pi's would cancel. So we could use our calculator to determine the actual angle of degree. So if I multiply 5 times 180 and divide it by 6, 5 times 180 divided by 6. If I can get my calculator to work, I end up with 150. Okay, so 5 times 180 divided by 6 is 150. So theta is 150. So you think about 150 degrees, which this is 5 pi over 6, which is 150 degrees. If you draw a theta degree angle of 150, what is the reference angle? Well, in the second quadrant, to find theta prime, you have to say 180 minus 150. Always drawing it back to the x-axis. So 180 minus 150 tells me that's a 30-degree theta prime. And 30 degree would be pi over 6 in radians. So for that reference angle of 5 pi over 6, your theta prime reference angle is pi over 6. Let's look at this problem and find the reference angle. Theta is negative 135 degrees. Now, this is the first angle that's negative. Negative angles are drawn clockwise. So negative angles will be drawn clockwise this way. So this is down to negative 90 and on around to negative 135. So to find my reference angle here, I will simply say 180 minus the 135. When you subtract, you get 45 degrees. Reference angles are always positive. So we have the 45 degrees, but actually our theta is negative 135 degrees, okay? So, because all you had to do was just subtract, because you're drawing all of these reference angles back to the x-axis. So anytime that you have an angle like this, you will just say the 180 minus the 135 gave me 45. So therefore, theta prime is 45 degrees. So I would use 45-degree reference angle here in this problem.